ಸರಿ. ಸರಿ.
ಈಗ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಔಟ್ಪುಟ್ ಬರಬೇಕಲ್ವಾ? ಸರಿ ಆಯಿತು. ಅಷ್ಟು ಈಗ
ನಾ ಈ ಕಡೆ ಬನ್ನಿ ಸರ್ ಅಂತ.
ಈಗ ತೆಗೆದು ಬಿಡಲ ಹಿಂಗೆ ಈಗ ಇದರಲ್ಲಿ ಸರ್ಕ್ಯೂಟ್ ಆಗಿದೆ. The aim of the experiment is SCR controlled half-wave rectifier and full-wave rectifier using RC triggering circuit. See, in this experiment here, we are calculating the rectifier output but using SCR. That means using the half-wave rectifier or full-wave rectifier without SCR. Okay, complete 180 degree it will conduct in the half-wave rectifier, or in full-wave rectifier complete the 360 degree it will conduct. But using this SCR triggering here, we can control the some amount of angle. That means here we can control 18 degree, 36 degree, 72 degree, and like that, both in the half-wave rectifier and the full-wave rectifier. And this is the overall circuit diagram here. Then according to the half-wave rectifier and the full-wave rectifier, this is complete half-wave rectifier, full-wave rectifier, but using the bridge. But according to this one here, here one rheostat is there. Then using that one, we can connect the load. Then similarly, one more potentiometer is there. Using that potentiometer here, we can control the firing angle here. Okay, this is the overall description here. Now if we connect in the circuit, this is the overall circuit model here, Then similarly, this is the one more circuit using bridge. Then according to this one, how we have to connect in the sense, see here, the primary of the the rectifier, that is 230 volts is there. Secondary is 24 volts is there, 24 volts AC. Then using this bridge here, using the diode, we can convert the 24 volts into the 5 volts, right? Then afterwards here we are connecting to bridge here. This is 24 volts AC is there. This one we have to connect here, the same thing here, one end. It is connected to the here, one top here, like this one. And similarly you have to connect it to the bottom here. Like that we have to connect. This is the top one side, positive of the phase, negative of the phase, like that. Then similarly, now afterwards here we have to, one end of the load is connected to the rheostat here. That's what here. This one you have to connect it to rheostat here. Then rheostat is same as the potential variable resistor here. We have to connect one end to the rheostat. Then other end here we have to connect it to the SCR, the anode it is there. These two have to make it common here. Then for this end or this end, we can connect the other end of the rheostat. Okay, this part is over. Next, then here part it is there, the variable resistor, and then after this one here, okay, you can connect by default inside already connected to which one to SCR. Then other end of the which one potentiometer, we are connected to which one which is capacitor here, right? And then this end we have to connect it to capacitor. Other end is connected to which one, the cathode here, and this cathode is connected to the other phase of the transformer. This completes the overall connection here. Then only thing is we have to find out the output using CRO, that is the graphical way. Then similarly, using the potentiometer here, the voltmeter, multimeter, you can find out the voltage, because you already know that here one thing is firing angle, second thing is conduction angle. That is conduction angle beta is equal to 180 minus alpha. Alpha is the firing angle here. Then using this variation of the part alpha here, for here we are considering for one complete cycle 180 degree, in the sense 10 divisions are there, each division is 18 degree, then totally 18 into 10 in the sense 180 degree. Use if suppose if 1 degree the one division is not conducting, in the sense 18 degree is not conducting, 2 division means 36 degree, 3 division means 54 degree, 4 division means 72 degree. Then here according to the this is the one according to truth table, one is alpha, it is there, second is VM, that is the peak voltage. Okay, next one is the overall output DC voltage, VDC is equal to VM by pi into 1 plus cos alpha. This is for the full wave rectifier. For half wave rectifier, VM by 2 pi into 1 plus cos alpha. That is the which one using the formula method what you are observing, that one. Then you have to find out the output voltage. Output voltage using the multimeter. Okay, suppose if both which one the calculated voltage and the output voltage both are one and the same, then it is understood that we are considering the in the real time operation how we can control the which one rectifier output using ACR. Now we can go for the output. We are connecting to the one end of the rheostat and the other is the other end of the rheostat, because using this rheostat here, we can take the load and also we can calculate the output here. That is using CRO and using the multimeter also. Using CRO, I can find out the peak voltage, and then we can use the theoretical output using the formula. But using the multimeter, you can find out the practical value. Connected to then the multimeter you have to connect here.
ಇದು CRO ತೋರಿಸಿ ಅಲ್ಲಿ ಔಟ್ಪುಟ್
ಕನೆಕ್ಟ್ ಆಗಿದೆ. ಸರಿ ಇಲ್ಲ ಸರಿ ಇಲ್ಲ ಸರಿ ಸರಿ ಇತ್ತು ಸರ್. Okay, this is the output of the which one half wave rectifier, and it is controlled by the SCR. see here, actually here 180 degree, that is the positive cycle, and the 180 degree negative cycle, but negative 180 degree it is not conducting, only positive 180 degree is conducting. And one more thing here, it is not conducting completely 180 degree in the positive cycle. Some angle, that means from here to here, totally 10 divisions are there. That means according to here, one division means 18 degree, then totally 180 degree. But using this part or potentiometer here, we can vary the overall output. That means some amount of power we can consume. That means using the particular, we can control using the rheostat here. Then here, first you have to, according to this one, this is the starting here, and till up to here it is conducting, then remaining one division is not conducting here. And this is the output of the half-wave rectifier. Then according to this one, using the formula, it is alpha Vm and Vm by 2 pi into 1 plus cos alpha. You have to calculate. Output of the half-wave rectifier is as shown below. VDC is equal to Vm by 2 pi into 1 plus cos alpha. Then alpha is the firing angle here. Then one division is not conducting. It is understood that 18 degree is not conducting. Then the resultant output is VDC is equal to Vm. Here the Vm is equal to Vm is equal to 21.20 volts, that is the Vm. Then Vm by 2 pi into 1 plus cos alpha. Alpha is 18 degree. Then after that one, you can find out the output. VDC is equal to around 6.33 volts. Okay. Same thing you have to analyze in the output using the multimeter. Some minimum around
6.62.
Lower value. And one more thing here, it is difficult to tell exactly 18 degree, because on an average you can tell it is exactly 18 degree. This is for one reading. Similarly, for two divisions, in the sense here, two divisions. The resultant output is for 36 degree 5.87 theoretical output is there. Similarly, practical output around 6.4 it is there. And for three divisions here, theoretical value is 5.15 is there. Then output is 5.68 or 5.57, like that it will come. Almost the little bit small difference is there. Remaining everything is same. Then for four divisions here, from here to here, okay, total from here to here 10 divisions are there. Under that 4 division is not conducting, that means 72 degrees is not conducting. Then the required output is, if you do in the theoretical way, you are getting 4.25, but now we are getting around 4.68 in the practical way. Similarly, for the last one here, if I vary, This is for complete which are 90 degree, the 5 divisions here. Then according to the theoretical, you are getting 3.21. Then practical, you are getting around 4.16. Like that, we can control the rectifier output using the SCR. This is the overall demo of the which one SCR control rectifier for the finding the which one firing angle and the conduction angle.